Hi everyone, welcome to today's Be Better to Our Planet Lunch and Learn event. Today's program is co-produced webinar series by the City of West Palm Beach Office of Sustainability and the University of Florida's Thompson Earth Systems Institute. I'm Elaine Christian, a Sustainability Program Coordinator with the City of West Palm Beach Office of Sustainability. Our main focus is conserving natural resources and reducing emissions within the City of West Palm Beach to ultimately create a healthy, ecologically sustainable, and resilient city. We're here to help you do the right thing, make a difference, and take care of our planet. We're striving to reach net zero 2050 by collaborating with you, our community residents, businesses, schools, and all city departments. This means reducing greenhouse gas emissions through less cars on the road, making our city more walkable, offsetting emissions by planting more trees, and more. You may be wondering, well, what does net zero and carbon emissions have to do with bees, right? Well, bees are affected by more than just pesticides, which our speaker will touch on later. Climate change plays a big role as well, and you can make a difference yourself. I encourage you all to visit our webpage, wpb.org/green. You can sign up for our newsletter on that page, and I also encourage you to visit our social media pages too, which are WPB Green on Facebook, Instagram, and Twitter for more information on the various programs and free resources that we offer to help you make a positive impact on the world around you. One such program is this one today. We're so happy to be partnering with UF's Thompson Earth Systems Institute for today's program. And now I'm going to hand it off to Stephanie with the Thompson Earth Systems Institute.
Hi, Elaine. Thank you for that. The Thompson Earth Systems Institute, or TESI, is located at the University of Florida's Gainesville campus. Our mission is to advance communication and education of Earth system science in a way that inspires Floridians to be effective stewards of our planet. What are Earth systems, you ask? This is the interaction between air, land, water, and life, and how we influence them. We do this through three main program areas, the first being our Scientists in Every Florida School program that aims to build long-term relationships between teachers and scientists in order to inspire the next generation of environmental stewards. Our team of trained communicators and educators also put forth public program like this event today and produced digital content in order to help people engage with science in a meaningful way. Lastly, we help both our scientists and our journalists hone their communication skills through our science communication professional development programs. Our vision is to lead the way to a healthier planet by cultivating a responsible and curious society that values, trusts, and has access to science. We also want to encourage you today to sign up for the Earth to Florida newsletter. This monthly bulletin is a curation of state's environmental news, and it explains what's going on, why it matters, and what you can do about it. We will put together the subscribe link in the chat box for you in just a bit if it piques your interest. You can also keep in touch with us by visiting us on social media at UF Earth Systems on both Facebook and Twitter, which will be displayed again at the end of today's program. So now we want to talk to you about who is joining us. We've got Galen Cobb, a PhD candidate at the University of Florida, studying changes in bees in Florida communities, as well as factors that contribute to those changes. Her work focuses on local bee fauna and non-native orchid bees that were first observed in Florida in 2002. She received her bachelor's in biology from the College of Worcester in Worcester, Ohio. And there she conducted research examining the exposure of fungicides on honey larvae. She also, prior to entering graduate school, worked in honeybee toxicology research at EAG Laboratories, a leading company that does ecotoxicology and regulatory science. Her general research interests include the genetics, behavior, and conservation of bees, wasps, and ants. As Galen tells you about her work, please be sure to ask your questions and put those into the chat box so that our moderator can be sure to get to them in a little bit. With that, Galen, what's all the buzz about?
Well, Stephanie, thank you so much for that introduction. And thank you all for joining me today to learn a little bit more about Florida bees and what they're doing buzzing around your backyard. So before I get started, I wanted to do some helpful tips. Remember, you can always ask questions in the chat by clicking the chat button at the bottom of the screen. There will be a question and answer session at the end of the presentation. And if you'll take note of the slide numbers at the bottom right-hand corner, that'll help make answering all those questions a lot easier. Thanks. Additionally, in some of the slides, there will be a little symbol, a little camera symbol, and that's to let you know that on those slides, you may want to take a screenshot because those slides contain useful information and references to resources that could be helpful for you later on. All right, so let's get started about what's the buzz about bees. So in the last 10 years, there's been a lot more talk about bees and their importance to us in our everyday life. And I'm gonna talk to you a little bit about why they're so important. So there's one word that can answer those two questions, and that's pollination. So bees are really crucial because the pollination services that they provide. Plants need bees to produce fruit and seeds, and bees do this by spreading pollen from one flower to another. Bees are known to contribute to the pollination of around 70% of our food crops, so they're quite crucial for our everyday life. And a large number of crops are actually entirely dependent on bees, even though bees are not the only pollinators out there. And part of this can be explained by the behavior I'm going to show you in this next little video. So what you see here is an eastern blueberry bee visiting blueberry flowers. So blueberry flowers are not like your average flower that you might have bought for your mother for Mother's Day. So those flowers, you can typically brush your hand across the top and you'll get a little bit of pollen across your hand. In blueberry and cranberry flowers, the pollen is actually held very tightly inside the pollen structures called stamens. So in order to release that pollen and make it accessible not only for pollination, but for the bee's own use, these bees will, okay, I have to click it, sorry. So these bees will vibrate at a very specific frequency. And when they vibrate, the pollen responds to that frequency and will shoot out of the stamen. So this is called buzz pollination or pollination by sonication. And it's one of the unique features that makes crops dependent on bees for pollination. Now, some of you astute viewers may have noticed in some of the background slides, I had a picture of a honeybee. This, of course, is a really popular bee and one that people have become increasingly familiar with. But the honeybee, also known as Apis mellifera, is not a native bee here in the US. It was brought over to the US by early colonists, actually, so it's been here a long time, for honey making and pollination. But we actually have over 300 native bees here in Florida. And a total of approximately 325 total species. So these native bee fauna is actually quite diverse and includes all 6 bee families present in the US. Now, interestingly, Florida has some of the highest rates of endemic species. We have 27, which is about 8.6%. So what is endemism? Well, endemism is when a species exists in a region and nowhere else. So that makes it pretty unique here in Florida. The tropical climate in Florida is what supports this endemism. So because we have unique environmental conditions here in Florida compared to all other connecting states, we're able to have this unique bee fauna. So when it comes to bee conservation, endemism and biodiversity are really important. And bee conservation has been a hot topic as of late because of the threats that we're seeing to bee species worldwide. So in 2017, there was a survey of North American bee species, around 1,400 bee species, and over half were assessed to be in decline. So these declines in these native bees are fairly serious and can ultimately affect the pollination services that they provide. Now, as researchers have learned more, we've come across 4 primary causes to these bee declines, including habitat loss, pesticide use, invasive pests and pathogens, and climate change. Now, these 4 work in conjunction. So those bee losses are often due to a multifactorial effects of these 4 factors. So as we look to understanding how to protect these bees, we really try to look at the bee community from 2 different factors, endemism and biodiversity. Endemism, as mentioned earlier, is important because it means they're unique to an area. So if there's loss of bees in that area, there's no additional populations that we can use to help recover that population. So endemic species are particularly susceptible to losses and thus are an important consideration for conservation. But additionally, we talk a lot about preserving biodiversity. Now, biodiversity is a word that gets thrown around a lot, but it actually has a pretty specific meaning. So biodiversity is made up of 2 different factors: richness, which is the number of species present in an area, and abundance, which is the relative amounts of those species in the area. So one way to think about this is, say you have a group of 5 species, and when you go out to sample, you find primarily one of those species. So you'll see the other 4, but you're almost always collecting that one. That's going to be considered less biodiverse than a group in which you have more even numbers of species, of the species present. So an important thing is that biodiverse ecosystems are considered healthy ecosystems. And this is because if you can have an ecosystem that sustains a high number of a lot of different species, then you know the underlying processes of that ecosystem are strong enough, are functioning strongly. So let's talk about Florida bee biodiversity. Next, I'm going to go through kind of a guide to the families that we see here in Florida and give you some little tips and tricks on how to identify each of them. I also want to talk about this photo right here because it's a bit of a special bee. This bee is the blue calamintha bee, which has recently been rediscovered here in Florida. So until this year, it hadn't been seen since 2016. And it's a special bee because it's one of our endemic bees. It's found in a 16-mile area of Lake Wales Ridge. So you can pretty much walk the entirety of its distribution, which is pretty special. So it's really nice to see that some of these bees that we're worried about can be found again, and perhaps that's due to conservation efforts. So the first group that I want to talk to you guys about is Adrenidae, or the mining bees. So these bees are ground nesters, and in fact, they're part of the majority of wild bees. 70% of our wild bees nest in the ground. So while we like to think about them in the trees, more often than not, they're actually below our feet. And the distinguishing feature for this group is these patches, these dense patches of hair found on their face. So these are called fovea, and they're kind of like little velvety patches, and you can actually see it here in the Florida, or in the photo here, where dense white patches of white hair. They are good pollinators, and they include some of the small species found here in Florida within the genus Perdita. So next is Apidae, and Apidae is one of the most diverse families in the world. Actually, it has the highest number of species, the largest number of species, and it includes a large number of bees, including the cuckoo, the carpenter, digger, bumble, orchid, and honeybees. So it has some of the more charismatic, the larger, the more familiar bees. Now, bees are often distinguished by where they hold pollen. So this can be a good way to be able to classify a bee. And one of the things that we see in many, but not all Apidaes, is something called a corbicula. So in the Drenids, they have these hairs called scopa on their legs that collect the pollen. But in apids, they have specialized structures, these pollen baskets. So when the bee goes up to the flower and gets covered in pollen, it grooms it down and packs it into that corbicula to store for later. And so you might see a friendly little bumblebee buzzing around, and you'll see a little ball of pollen stuck to its back leg. And that's a pollen ball stuck into that corbicula. This group includes the popular European honeybee. And like the European honeybee, a lot of these species are social. So social means that there's some social structure, that they'll live in groups, and that the groups are often made up of families. So you'll have, in the case of the European honeybee, a queen and her daughter workers. They're also known to be very good pollinators. So the Coletidae are a really unique group. These are the cellophane or plaster bees, masked and fork-tongued bees. And their distinguishing feature is their bifid or split tongue. So if you get up to one of these, get up really close and it sticks its tongue out, what you're gonna see is a long tube and a little fork at the end. They are solitary, but often nest in aggregations. So even though they're not helping one another to raise their larvae, they may be seen in groups, but that doesn't mean that they're social. In one genus, the Coletids, they have this really unique feature where they actually create a cellophane-like material to line their nests. Because as you might imagine here in Florida, one of the things that bees have to contend with is our crazy humidity. So just like we worry about our food going bad, these bees are storing food in their nests for their developing larvae. But these larvae are going to be in there for months at a time. So they have to find ways to ensure that the food they provide doesn't go bad for the larvae and isn't attacked by microbes. So one of the ways they do this is to try to control the humidity by creating waterproof linings. And in this case, the bees produce it themselves. So Halictidae is one of my favorite groups. They're quite beautiful. So these bees are pretty diverse in morphology or what they look like, right? So Halictus is one genus, and it looks similar to the Adrena bees in that it has a banded abdomen. So the abdomen, you can think of kind of like the butt of the bee. And in this case, what you would see is a little black bee with white stripes going down its abdomen. But very different from that, you have 4 genera, Ogochlorella, Ogochlora, Ogochloropsis, and Agapostemon, that are brilliant green and blue. They're iridescent. They shine like little gems under the microscope. It's quite something to see. And so these morphological differences are actually quite helpful in terms of identifying them. There is one other bee in Florida that has that green color. It's non-Halictidae, it's an Apidae, and that's the orchid bee that Stephanie mentioned that I'm working on. But a best bet when you see these iridescent bees is more likely than not it's going to be in Halictidae. And in addition so this group is the only other group that shows social species. But unlike the apids, they don't have such a strict social structure the way you see in honeybees with the queen bee and the daughter workers. In this case, you see daughters helping their mothers to raise their young, but these daughters have the ability to have offspring of their own. So now we get to the Megachilidae, or the leafcutter, mason, and resin bee. So those resin bees are also using waterproofing agents. Now, these are quite cute. I absolutely love these bees, and that's because their primary place for storing pollen is not on their legs like the Adrena, or the apids or the Caletidae. But it's actually on their stomachs, on the underside of their abdomen. They have large tufts of seedier hairs. And so you can kind of see it in this picture. You see the yellow underside of the bee. That's not a reflection, that's the seedy right there. They're solitary like many of the other wild bees. And the leafcutter bees, you will be able to tell if they're in your garden because they leave these really very remarkable half moon-shaped cuts in leaves. And instead of using resins or that cellophane material, they're lining their nests with rolled up leaves. So they're pretty distinctive. So these half moon shaped, you can tell that it's a bee and not just a garden pest because of the distinctive nature of that half moon shape. But yeah, keep a lookout for that in your gardens. And finally, we get to the Maletids. So Maletid bees are rare here in Florida. There's only 2 species found, and they live primarily in northern Florida. So for those of you in West Palm Beach, you're probably not going to see these. They like to nest in the sandy soils, and they're specialists. They only visit a single plant, which of course makes them a little more vulnerable if to declines. In particular, declines due to climate change. As climate change affects the distribution of these plants, these bees are then affected as well. They have no alternatives. So here I want to give you guys some resources. Identification can feel overwhelming. Trust me, I know. But there are some absolutely wonderful resources out there if you're interested in identifying your own bees. So one of the ones that I cannot recommend more is actually an app for your phone. So you can download this to any smartphone. It's called iNaturalist. It's very easy to use. You take a photo or a few, you upload them, and based off of those photos, it'll give you a list of possible recommended species identifications, which you can then sort through to pick the one that you feel matches best based off of the description and additional photos that they provide. So it's a really wonderful way to identify on the go. I have certainly used it for plants because plants are not my forte. And I think the best part about iNaturalist is you actually get to contribute to science. So all of these observations that you download into this app, go to their website and say you identified it and you thought it was an adrenid, but it turns out it was a Caletidae. Experts who are monitoring those sites will help correct your identification or confirm that what you thought you knew, you did, right? So it helps to ensure accurate identification, and then all those observations will go into a database that scientists can access to see the identification data, the date and time, and the location. And so this can provide a lot of information that researchers can use to learn more about bee populations and bee distributions. Another really wonderful resource that I've been very happy to come across is a Florida Native Bees Facebook group. I highly recommend people looking it up. The title is just Florida Native Bees. You can search for it by that. And it has wonderful regional experts that can get you, with a single photo, get you down most often to genus or even species. Of course, there are additional online resources that are truly wonderful. A lot of them are used best when you have more taxonomic knowledge or knowledge about fine-scale morphological traits, which you often have to observe under a microscope. So this might not be for the backyard observer, but if you want to learn more about bee taxonomy, Bug Guide and Discover Life Bees World Checklist are truly wonderful resources. Now, what can you do to help improve or to help conserve bees, right? Like at the end of the day, how can you make a difference? So we talked about those 4 factors that are affecting bees. And the first one was habitat loss, and that's huge. Habitat loss includes not only loss of nesting habitat, but also food resources. So there are some very concrete things you can do in your own backyard to help mitigate these factors, including protecting nesting habitat that may already be there and you didn't know it. So leaf piles, bare soil patches, and stumps and logs are really important. Remember, you don't have to cover every patch of soil with plants or decorations. Those bare soil patches make a world of difference for those ground nesting bees. You can also build your own bee house. This is a wonderful way to get more involved in providing nesting habitat for bees. But you have to keep in mind this is not a one-off activity. You cannot just build it and leave it. You have to maintain it throughout the year, or else these bee houses can end up turning into more harm than good. And I'll get to that in a little bit more detail in a bit. Finally, planting pollinator-friendly gardens is a wonderful way to add food resources to these bee communities. And one of the resources that I can't recommend more highly is the Xerces Society plant recommendations. So they have kind of info sheets that you can get from their website, and Xerces is Xerces, and they will give you a list of native plants that are good for bee pollinators, and they label them by flower color, bloom period, water needs, all the information you need to truly develop a beautiful pollinator garden can be found on their info sheet. So again, go to Xerces Society and you'll find some wonderful resources. Finally, I want to speak to pesticide use, personal pesticide use. Of course, the goal is to reduce how much pesticides we put out there. And in particular, if you're going to find ones to avoid, try to avoid neonicotinoids, including imidacloprid. But of course, you have a garden, perhaps a fungus is attacking your favorite tree, or tomato hornworms are attacking your food. Sometimes you don't have too much of an option. And so in that case, if you are going to use them, after having tried other methods, I would recommend spraying in the evening times. This is a really great way to mitigate the effect of that spraying, as most bees are not active, and many of these compounds have short half-lives, so that they won't have the same detrimental effect the next morning, right? So spraying in the evening time is a great way to, if you're going to use them, mitigate any effects that you might have. So I want to speak a little bit more about those bee houses and things you can do to make them the most effective. So maintenance of bee houses is critical, and this is because, as you might imagine, if you were to live in a house and never clean it, it gets a little dirty and gross, right? Well, the same thing happens in bee houses. So if you're not doing the maintenance to take out any nesting tubes that you include in there and replace them on a fairly regular basis, maybe every 1 to 2 years, then you're gonna get a buildup of pests and pathogens that can negatively affect the bee. So here on the left, you see an image of what are known as pollen mites. The other thing to consider is many of these species are solitary and perhaps don't live in aggregations. So creating something that's quite large, like the photo on the right, sometimes referred to as a bee hotel, is actually not the best. Not only is it not a natural setting for these bees, but it also can add to the buildup of pests and pathogens as these bees come in fairly close contact with one another. So building smaller units and maybe more of them placed spread out through the backyard would be a better option. Finally, here are some tips and tricks for gardening around bees. Wearing loose clothing that are neutral colors. Bees are mostly attracted to whites, blues, yellows, and purples. So those colors are going to be particularly attractive, and you might get bees inadvertently flying towards you and not your flowers. So loose clothes or neutral will help avoid attracting the bees, and if they do get on you, making it easy to kind of brush them off. Of course, staying calm, hands down, no kind of aggressive movements. These bees are generally not out to sting anybody. They're out for foraging for pollen and nectar. So if you're calm and don't come across aggressive, they're more than likely not going to get aggressive in return. But if you are stung, which happens, trust me, I know, it's best to scrape out the stinger. If you actually go to try to pull it out, you can inadvertently squeeze the toxin sac that's attached to the stinger and actually put more venom into the affected area. So try and scrape, don't pull. And finally, a kind of fun one is don't eat bananas. So honeybees, when they sting, they give off an alarm pheromone. And that alarm pheromone, actually, the primary compound found in that alarm pheromone is the same one that gives bananas their scent. So avoiding eating bananas can help avoid making particularly honeybees more aggressive. Thank you guys so much for listening to my presentation, and I will be answering any questions that you have now.
Galen, thank you so much. So I'm excited to jump into our question and answer portion with you. Our first question for today comes from Wendy, who asks, what is the best way to relocate bees who have made a hive in your attic?
Yes. So it would depend on the bee. If it's a honeybee nest, I would contact your local beekeepers associations. These are experts who know how to handle them, and what they can do is they can go and they know exactly how to identify, locate, collect the queen, and once the queen is removed from an area, the rest of the bees will go to her. So often this is really something that beekeepers will love to do even for free, because that gets them a free hive. Essentially, they can then take that and put it into a hive and beekeep. So yeah, beekeepers associations, if you're dealing with honeybees. If it's another bee or a wasp, I know, so I've also studied wasps, and they have a place in my heart. I know most people can't say that. But unfortunately, sometimes you know, with an aggressive wasp nest, you'll have to spray, and sometimes there's no getting around that. I will say paper wasps tend to be very timid. They don't sting as much. So as long as they're not right up in your space and maybe off to like a side eave of the house, I generally would leave a paper wasp nest. Yeah.
Galen, our next question comes from Mike, who asks, what percentage of honey do bees have to, what percentage of honey do they have to live in a hive so the bees don't have starved to death over the winter?
Yes. So as any experienced beekeeper knows, you do have to leave some honey reserves. To be honest, I've never been a beekeeper. So the ins and outs, the specific percentage, I'm not sure. I think it would honestly depend on how productive the bees. If the bees had been extremely productive, then you could possibly take a little bit more. But of course, they're also, if they're super productive, probably far larger, and thus will need more resources. So I don't have an exact percentage that I could tell you. Yeah, I would imagine it's on the range of like 30 to 40, but that's kind of thrown out there. So I would reach out to beekeepers associations. They'll have all that really good information for you too.
Julia is curious, do all bees sting?
No, there are some stingless bees. Most bees that you'll encounter here in Florida will sting, but are very rarely going to sting. So you can be, if you see a bee flying around you, so I do collections of bees. I actually go out seeking them, right? And so I'll sometimes be in an area with like 20 bees buzzing around me. And as long as I'm there, calm as can be, I have yet to get stung during my collections. I really have only had to deal with stings when I'm actively going into hives or nests. Yeah.
Daniel
Also
asks,
males don't have stingers. So if you encounter a male bee, which there are different ways to tell if it's a male or female, but they will not sting you at all. You can just hold them and handle them, and yeah, it's pretty cool.
Sounds good. We have time for just a few more questions. Our next one comes from Daniel, who asks, I know bees are very important for our food production, but is that a specific type of bee or all bees?
That's a very good question. So a lot of emphasis in agriculture has been on the honeybee because honeybees are managed. They can be moved around. But like I mentioned earlier, certain crops require this thing called buzz pollination, and honeybees cannot buzz pollinate. So native bees are often really important for the pollination of crops. And in fact, a lot of times there are bees that are specialists on crop plants that honeybees can pollinate, but not nearly the same efficiency. So while honeybees are in the big picture an important pollinator of our crops, we cannot forget about our native bees that provide more targeted pollination for some of these crops.
Stacy asks, if they nest in the ground, how do they stay safe when it rains?
That's a very good question. So I think that comes down to nest design. This isn't something that I study specifically, but a lot of times the nests don't go straight down. They have little like caverns that shoot off. So what they do is they go down, they build these little side tunnels so that if the water comes down into the hole that they built, it's not going to necessarily flood them out, right? But additionally, they're lining those holes, like the cellophane bees that I mentioned, with a waterproofing material. So as water soaks into our sandy soils, it's not getting into the cavities that they're placing their larvae into.
And our last question is going to come from Barbara, who asks, on slide number 9, how do you distinguish carpenter bees from apidae?
Yeah, carpenter bees are an apid bee, so they fall within that group of apidae. And the ones that they're most often mixed up with are bumblebees, right? Bumblebees and carpenter bees, they're both larger bees, like the size of a quarter, I think would be a good comparison. But the bumblebees have hairs that go all the way down their abdomen, that butt of the bee, right? Whereas carpenter bees have really smooth abdomens. So that's a great way to distinguish between two very similar groups.
Galen, thank you so much. Is there any final thoughts you would like to leave our attendees with today?
I guess I would just like to say, I hope that you guys can share or feel the same love that I have for bees. They're really remarkable creatures. They do so much for us. And yeah, just get out there and help build a bee house or help conserve habitat.
Well, again, thank you so much. We really appreciate it. At this point, I'm going to hand things over to Elaine for some final remarks.
Thank you so much, Brian. And thank you, Galen. Your passion really shines through, and we have learned so much from you today. So thank you so much. We want to thank everyone for joining us on the call today to talk bees. You can learn more about our guests and each of our programs by visiting the website seen on your screen. You can also find a recording of today's program on the UF Thompson Earth Systems YouTube channel. Thanks so much to Galen and to you all for joining us on today's call. Until next time, bye-bye.